All right, so in your book, you actually have a table that summarizes it all. And so these are my pair in geometries. And so you can see here electron groups, how many? 2 is linear, 3 is trigonal planar, 4 is tetrahedral. And then here I've got 5 is trigonal bipyramidal and 6 is octahedral. And then if it is a subgroup, so if I have no lone pairs, then it's just my electron geometry and my molecular geometry are the same. But instead, if I have 1 lone pair or 2 lone pairs, some of these electron groups become lone pairs, then now I have a different molecular geometry. My subgeometry is going to change. And remember, those end up being the less thans. And so you can see some examples. You should be able to count and say, okay, well this is 3, so it's trigonal planar, and they're all bonds, so it's just trigonal planar, trigonal planar. This is 3, which means it's trigonal planar, but one of those is a lone pair, and so this is the subgroup of trigonal planar, which is bent, okay? And so you want to be able to use this table, read this table, understand how to use it. And so with that, now you can start predicting the shape. So if I asked you, what is the shape of this molecule? Well, the first thing you have to do is you have to be able to draw the Lewis structure. You can't predict the shape if you don't know what the Lewis structure looks like. So draw the Lewis structure, figure out the number of electron groups are on the central atom so you can get that electron geometry. Then are there any lone pairs? How many? To figure out if it's a subgroup. And then you can use that table to determine what that shape is and what those bond angles are. So let's do a practice. Predict the molecular geometry, so that's that subgroup of the family. Predict the molecular geometry and bond angles in SiF5-. So I need to first draw the Lewis structure of that. So now I need to refresh what were my steps for drawing Lewis structures. So the first thing is I have to figure out who goes in the middle, Si or F. So if I go to my periodic table, here's Si and here's F. Si is less electronegative, so it's going to go in the middle. So Si is going to go here, and then I'll put F around it. And if you start thinking about how many things you have to put around it, you start almost drawing it in the geometry itself. Now I need to add up my electrons. Si is going to have 4, F is going to have 7. So I have Si, I have 1 of them at 4. I have fluorine, I have 5 of them at 7. So that gives me 39. Wait, I can't have odd, but we have a charge. So since it's negative, I add however many there are. It's a -1, so I add an electron. So I have 40 total electrons. Next step is to make single bonds. So I make single bonds everywhere. I made 5 single bonds. Each bond has 2 electrons, so that's 10 total electrons. So I just used 10 electrons. All right, next is to make this outside guy happy. Fluorine wants 8. He has 2 right now, so he wants 6. They're all the same, so 6, 6, 6, 6, and 6, and so that would be a total of 30. I have 30, so I could do it. So I give everybody 6. Okay, so everybody has 6. That's 30. I'm done there. Next I say, is the Si happy? He's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I forced him to expand. Let me make sure I did that right. Can Si expand? Yeah, he's in row 3, and he had to expand because there was 5 fluorines. So I don't even have to worry about checking anything. He's expanded, he's extra happy, so we're good to go, okay? So now what I want to do is figure out the geometry. So I look and I say, okay, there's 1, 2, 3, 4, 5 things on. So he has 5 things, 5 electron groups, and they are all bonds. So now you could go to the table and say, okay, I need 5 electron groups, because this part says electron groups, so I need 5. So here's my 5. But they were all what? They were all bonds. So that means, if I go here, it's bonding groups and lone pairs. So I have 5 electron groups, 5 bonds, no lone pairs. So it would be a 5, 5, 0. So a 5, 5, 0. My electron geometry is trigonal bipyramidal, but I molecular in this problem. So the molecular geometry is trigonal, bipyramidal, and my angles are 120 equatorial and 90 for axial. So that's how you use the chart. So if I asked you, your molecular geometry, we said, is going to be trigonal, bipyramidal. And the bond angles, we said, were 120 for equatorial and 90 for axial. Okay, so that's how you would figure out the molecular geometry on a compound and the bond angles. All right, so on the next lecture, we're going to do another practice problem.